Hi guys, I want to make this as user-friendly as possible for you. What we're doing here is we have a function, a curve of that function drawn up here. There's no actual numbers or algebra to it, it's just a function, function x. There it is in black, undulating up and down. Our mission is to draw the equivalent corresponding slope function down here. Now the slope function, or the first derivative function, indicates where the slope is increasing and where it's decreasing, rising and falling. So how we're going to do this? Well, first of all, one of the easiest things you can do, or simplest things, is to mark out and identify where the stationary points are along here. Why is that? Because the stationary points, the equivalent on the first derivative function, will be along the x-axis, along here. Now, if that's the x-axis, and this is f prime x, or dy dx along here, then the stationary points are on the x-axis. Now, what's above the x-axis? That's where we have a positive slope, and that's where it's increasing or rising. And below the x-axis, that's where the slope is decreasing or falling. So I'll put a minus sign right over there. And again, as I said earlier, I know I'm repeating myself, the x-axis along there will indicate the stationary points. So why don't we go ahead and find the stationary points first, because that's always ideal. So let's mark them out. So here's our curve. Where are the stationary points? That's when the slope equals 0, the gradient is 0, it's horizontal. That would be along there. There's our stationary point. Where else do we have a stationary point? We have one. Yep, we've got two more. We've got one here. There we go, stationary point across there, horizontal and level. And the next stationary point would be here where the slope equals 0 right there. There we have our three main points that we can see. That's what we're interested in. Now all we have to do is find the corresponding points along here to match them. So where do they match? Well, it matches, a stationary point here matches the x-axis. So that would be there. And we would have a stationary point here would match here on the x-axis. And finally, we'll have one stationary point just over there. Okay, so now all we have to do is fill in the gaps and draw the slope function down here. Now, before we do that, I like to always mark out, to make it easy for you to understand, is where it's rising, like here, and where it's falling, like here. And what I like to do is put pluses and minuses. So let me put the pluses along here. So this would be rising all the way along here until it reaches there, which is 0. And then it would be falling along here. I'll put some minus signs. Falling along there until we get to the stationary point. Then what does it do again? It starts to rise. So the curve here is increasing right there. And again, after this stationary point, it starts to fall down again. So it's decreasing. Okay, so we've marked them out. Now that's really useful and helpful for us to actually draw the function down below here. So let's go ahead and start to do that. And let's see how it's going to look like. So down here, from here to here, it's rising. So because it's rising, all we care about down here is not the slope, but rather if it's above or below the x-axis. That's all we care about. So since this is rising along here, let me just put that in red. Rising. All this section here is going to be which part of the axis, above or below. It's going to be above the x-axis. So that means this, until it hits the stationary point here, will be above. So if we're going to come from above, we can't come from here, we've got to come from here. So that means the curve will be doing this. It's coming like that, like that. Now you may look at the slope and think, but that's a negative slope. Well, that's not the slope we're interested in. We're interested in being above or below the x-axis. We can't come from here because that's negative. So there we go. That's the slope function until we hit the stationary point right there. Then what does it do? Then it starts to drop. It's decreasing, as you can see here, until the next stationary point. So that means it's going to what? It's going to be dropping, decreasing. So which side of the axis are we doing now? We're going to be dropping down, decreasing on this side. So it's going to go down into here, below the x-axis. Cool. All right. Now, until there, it's going to be below. Then it's going to start rising. So we got to play with it under here until we hit there. So that's all below the x-axis. As soon as we hit the stationary point, as you can see, it starts to what? Rise. It's increasing. So that means from here to there, it's going to be above the x-axis, so it's rising. Until it hits that stationary point again. And what's happening at that stationary point? It starts to fall again. So that means it's going to go down like that. Just darken that up. So let's have one more look at it just to confirm what we've done. The first thing we did is take the stationary points and mark them out. Then bring down the corresponding stationary points onto the x-axis. Then what we did is put the pluses and minuses to indicate increasing and decreasing, and then we just transfer the corresponding increasing here with above the x-axis, decreasing below the x-axis, increasing above the x-axis, and decreasing here below the x-axis again. And there you have it.